Hey, so this is us starting the calculator paper. So slightly longer than the non-calc paper. We've got nearly 2 hours. So actually bodes quite well, doesn't it? Because I think people feel a bit more comfortable with a calculator. So you've got more marks to be had in this paper than the other one. So if it was the other way around, like people would feel more awkward. So and that's quite good. It's a longer paper, but you've got your trusty calculator, and yeah, more marks you can get here, the better your overall average will be. So let's start off, as always, fractions and percentages make an early appearance just to settle you into the paper. When I'm doing these questions, I tend to, computer's thinking away, highlight the important information. So you've got a year, you've got an amount, you've got a percentage, and there's your final year. So you should be thinking to yourself compound. Okay, when you've got time and a percentage, that's your compound. Now the actual equation I teach is the amount multiplied by 1 plus or minus the percentage over 100 to the time. So for this one, you've got 250,000, and you're going to times that by 1, and we're increasing. So just watch the word there, increase. If it was a decrease, or depreciate, you'd be taken away. And our percentage is 4 over 100. And the time here, well, it was built in 2020. Okay, so it was built in 2020. So 2021, 2022. So expected to rise 4% each year. The expected to rise that. So I'm going up 1, I'm going up 2 years. Yeah. So I'll put a little 2 in there. So that's going to come out as this. Now you can just type that straight into your calculator, but it's just to show you. Some people go straight for this line, and that's absolutely fine. You can go straight here if you want. The reason I do this is to make sure you don't make the silly mistake of doing 25000. I'm increasing it by 4%, so 1.4. That would increase it by 40%. Okay, an increase of 40%. So if you always do this, you won't run into that mistake. And actually, because of BODMAS, your calculator, if you do it like this, your calculator does all turns it into that. You don't have to worry about changing it. So if we do that on our calculators, again, get used to your calculator. You should come out with 270400. Now, a lot of the time they ask you to round this. This question hasn't asked me that. If it did, you would still write your answer from your calculator, then you would round it. And just to go over it, say they wanted that to 3 significant figures. There's 1, 2, 3 significant figures. Find your place, look next door. 5 or greater, add 1 more. So this would become 270000. I need the 3 zeros for place value. I don't want any zeros for after the decimal, because I don't need them for place value. So yeah, should be a nice easy question. Just take your time. If you've not got a time, it's probably going to be a reverse the change question. Okay, where you start off with an amount equals a percentage. Next one. Scientific notation questions. So people don't like these questions because the numbers are all a bit mental. But just have a wee think of what it's saying. Light travels at 3 times 10 to the 8 meters per second. Okay. A star is that many meters away. Calculate the number of seconds it would take to reach Earth. Okay, well, you could do a speed equals distance over time calculation, couldn't you? And say, well, if you're looking for the number of seconds, if you're looking for time, then you're going to say distance over speed is going to be equal to time. You could do that. But if you're not sure about that, well, let's think about it. You're saying that you can go 3 times 10 to the 8 meters in 1 second, yeah? And you're trying to get to 4.2 times 10 to the 17 meters, and you're saying, well, how many seconds is that going to be? So you have to times them by. So if that was nicer numbers, say that was 1 and 5, you'd be saying 8 times by 5, but it's slightly different, weirder numbers. How do I get from here to here? Well, you could do this. You could divide by this itself and then times by that. That would get you up to there. Let me just show you that. Okay, so if I want to get to 1 meter, I need to divide by this number. Do I divide by itself? So that'll give me 3.333333 times 10 to the negative 9 seconds. And then how do I get from here to here? Well, I'm timesing by this number, aren't I? So first of all, I divided both sides by 3 times 10 to the 8. And then I multiplied by 4.2 to times 10 to the 17. So that times 4.2 times 10 to the 17. And that should go into that. Well, yeah, so that's going to give me 2, 1, 4, 1, 0, 1, 2, 3. Yeah, I've got 8 zeros there. 1, 2, 3, 5, 6, 7, 8. So in scientific notation, that would be my decimals here. So I need to move the decimal once, twice, 3, 4, 5, 6, 7, 8, 9. So that's the same as 1.4 times 10 to the 9 seconds, because this number here has to be between 1 and 10. Okay? Can't be 10, it has to be 9.999. 1's okay. Yeah, so that's why I put the decimal in here. So yeah, I think the easiest way is to just do speed equals distance over time. But I just thought I'd show you this because this method works for some of the other forms of this question. And it's just trying to relate, don't stress about the numbers, just think, wait a minute, what if that was, 10 equals 20? How would I get that? Just what we usually do if that's 70%, we would divide by the 70 and then times by the 100, So don't get stressed out just because they're big numbers. You can use this process for the scientific notation questions as well. So yeah, you get a mark for knowing the correct methods. Actually, in this case, we're going to mark for basically doing this, then a mark for your final bit. Okay. And actually, sorry, the first section with your 3 marks, you get a mark for your decimal multiplier. You get a mark for knowing how to use that, like with the square as well, and then a mark for your final answer. And factorizing, so more of a non-calculator skill than a calculator skill, but okay. So when we're factorizing, the first thing we always do, I'll write it over here, we take our common factor. Okay. Once we take a common factor, we need to decide, is it a difference of 2 squares? Or is it a trinomial? So difference of 2 squares, like, x squared take away 49. So it's x take away 7, x plus 7. Yeah. Also, it doesn't matter if that number is in front, it would still be the same. That'd be 7 take away x, 7 plus x. Yeah. So doesn't matter if it's an x or a number in front, it's a difference of 2 squares. And this is the square root of this number in front, and then the square root of the second number at the end. The trinomials add to give you the middle number, multiply to give you the last number. So in this case, call that 5, so x plus 5 and x plus 5. The difficult trinomials are where you've got a number in front of the x squared, so something like 2x squared, plus 10x plus 8, something like that, okay? When you've got that, you've got a slightly harder method, so I'd go watch one of the other videos for that, okay? But if you remember this, that's most of your factorising done. So for this one, obviously a common factor out first, so that's a squared take away 25, and then you should spot that you've got a difference of 2 squares, a take away 5, a plus 5. Yeah. The only time you would factorise in the calculator paper with a calculator is when you're using your equation here. This will take an equation and work out the roots. Not technically factorising, but don't forget factorising here. If we then were to solve that, if we said, okay, when is that equal to 0? That's us trying to solve, So we then say, well, a can be 5 and a is negative 5. And that would tell us that the roots of this equation are at 5 and negative 5. Okay, so the only time we do this with a calculator, so it says factorise or solve the equation, to 2 decimal places, we would use this equation up here. But when you see the word factorise, you're really thinking to yourself, okay, common factor, difference of 2 squares, and trinomial, that's your main ones. And the difficult trinomial, check a different video. Okay, so I think I'll stop there, and we'll carry on with this one in the next video.